Question number 1 of worksheet number 4A on page number 14. Right, question number 1, the nth term of a sequence is 6 minus 5 and write down the first 3 terms of this sequence. So we write 6 minus 5, instead of n we write 1 because we need the first term. N is the number of terms. So for first term you write 1 and the answer for 6 minus 5 is also 1. For the second term you do 6 minus 5 times 2, the answer is minus 4. For the third term you replace n with 3, so the answer is minus 9. This is how you find the first 3 terms of any given sequence. You just substitute 1, 2 and 3 instead of n. Alright, part B, the nth term of another sequence is 5n square plus 3. Now if we had to find the first term of this sequence, the sequence is 5n square plus 3. If the question was find the first term of the sequence, we would have done 5 times 1 square plus 3, the answer would be 8. If we were supposed to find the second term of the sequence, we would do 5 2 square plus 3, which would have been 5 times 4, 20, and then 23 would be the answer. But this is not the question. The question is 848 a term in this sequence? So for that you need to check, you equate this to 843 and you need to check what value of n is giving us this answer. So if your value of n is an integer number, for example 3, then that means the third term of this particular sequence is 848. If your answer is something like 3.1 or 3.2, we will say that this 848 is not a value in this sequence. So you simply simplify this equation. We subtracted minus 3, then we've divided 5, then we take under root on both sides and we get 13. So that means the 13th term of this sequence is 848. If the answer was not an integer value, then this 848 would not have been a part of this sequence, a number in this. Question number 2. Here is a sequence A, 13, 9, 3, minus 5, minus 15, B. Find the value of A and B. First we need to see what is the pattern being followed in this sequence. Let's see how this 13 is changing into 9 by subtracting 4 from it, right? How is this 9 changing into 6 by subtracting 6 from it? How is this 3 changing into minus 5 by subtracting 8, then by subtracting 10? Which means to get B we have to subtract 12 from it. So minus 15 minus 12 will give us minus 27. So this is the value for B. Please note the answer to this question is wrong. The answer is actually 15 and minus 27. 15 and minus 27. Alright, now how do we find A? What needs to be written over here? Minus 2, right? So what minus 2 is equals to 13? That is A is equals to 15. So this is the other answer. 15 and minus 27. Question number 3. These are the first 5 terms in a sequence 8, 11, 14, 17, 20. Find the next term of the sequence. So for that we have to observe what is happening over here. How is 8 changing into 11? By adding 3, then again add 3, then again add 3, and to get the next term you have to add 3 to 20 and we get 23, which is the answer for part A. Part B, find an expression for the nth term. So for that you either use the formula A plus B n minus 1, since this is the first level common difference, or also called the linear sequence. A is 8, the first term, D is 3, the common difference, times n minus 1. When you open and simplify you will get this answer 3n plus 5, right? The other method we discussed to find the nth term for a linear sequence was that directly write 3n first. 3 because of this 3, the first level common difference is 3, so we write 3n. Then when I substitute n is equals to 1, I am getting 3, but the actual first term is 8, so I need to add 5 to it to get 8 when I substitute n is equals to 1. So this way you can directly get the formula for the nth term of this first level common difference sequence. Question number 4. These are the first 5 terms of a sequence -4, 2, 8, 14, 20. Find an expression for the nth term of the sequence. So let's observe the pattern now. We're adding 6 here, then we're adding 6 here, and so on. So this is again a first level common difference sequence. So either use the formula, which I will not prefer, which is a plus d n minus 1. Write the first term plus d is the common difference times n minus 1. Open brackets and simplify, you get minus 10. Minus 6 minus 4 is minus 10. So you get 6 and minus 10. How to do this directly? Directly write this 6 and n. Now when I substitute n is equals to 1, my first term is 6, but the actual first term is minus 4. So I need to subtract 10 from this to get minus 4. So this is how you get to the answer directly. Question number 5. Here are the first 4 terms of a sequence 23, 17, 11, 5. Observe the pattern, what is happening. We subtract 6 here to get 17 from 23. Then again subtract 6 to get 11. Then again subtract 6 to get 5. So this is also a first level common difference sequence, or also called a linear sequence. Find the next term. For that, simply subtract 6 from 5 and you get minus 1, which is the answer for part A. Part B, if you're using the formula, you will use a plus d n minus 1. A is 23, the first number of the sequence, plus d is actually minus 6, the first level common difference, times n minus 1. So we've used the formula a plus d n minus 1, where a is the first term, d is the common difference. Okay, when you'll open the bracket and simplify, you'll get this. Okay, how to do this directly? Directly write minus 6n. When I substitute n is equals to 1, I get minus 6, whereas I should get plus 23. So what do I need to add to minus 26 to get 23? That will be 29. So simply add 29 here and you directly get the formula. Question number 6. 7, 5, 3, 1, minus 1. Find the next term of the sequence. Observe that we're subtracting 2 in each case. So to get this term here, you subtract 2 from minus 1 and you get minus 3, which is the answer for part A. Part B, find the nth term of the sequence. So I'm not going to use the formula now, I'll do it directly. You may use the formula if you're more comfortable with that. So my common difference is minus 2n. I write minus 2n. When I substitute n is equals to 1, my first term is minus 2, whereas the actual first term should be 7. So what do I add to minus 2 to get 7? That is 9. So I write 9 over here. Question number 7. These are the first 5 terms of a sequence 13, 8, 3, minus 2, minus 7. Find the nth term of the sequence. So to get to 8 from 13, we have to subtract 5. Again we subtract 5 over here to get 3, then again subtract 5 to get minus 2, again subtract 5 to get minus 7. So this is a first level common difference where the difference is minus 5. So without using the formula, minus 5n When I substitute n is equals to 1, my first term is minus 5, whereas the actual first term needs to be 13. So I need to add 18 here to get 13, so add plus 18. Or if you want to use the formula again, first number is 13 plus d is minus 5, n minus 1. When you open and rearrange, you'll get the same answer. Question number 8, part A. The sixth term, these are the 5 terms of the sequence. The first 5 terms are 32, 25, 18, 11, 4. Find the next term, which is the sixth term. So observe what is happening over here. We are subtracting 7 here, then again subtracting 7 here, then again subtracting 7 here. To get to the sixth term, we have to subtract 7 from 4, which gives us minus 3. Part B, find the nth term. So for the nth term, I'm using the direct method. I write minus 7n. When I substitute n is equals to 1, my first term is minus 7, whereas the actual first term needs to be 32. What do I need to add to minus 7 to get 32? That is 39. So I write plus 39 here. Or use the formula again, which is a first term plus d, which is minus 7 times n minus 1. Open the bracket, simplify, you'll get the same answer. Alright, part C. Which term is the value of n? Which value of n is equals to minus 332? So you write the formula minus 7n plus 39 is equals to minus 332. So this, it has a subtraction minus sign with it. So rearrange and simplify, so we get 39 plus 332. 7n will go to the other side, and then we'll bring 7 to the denominator. So this should give you 53. So n is equals to 53. Question number 9. These are the first 4 terms of a sequence 5, 8, 11, 14, part 1. Write down the next term. So this is, we add 3 here, then again we add 3 here, then again we add 3. So the next term will be 14 plus 3, which is 17. Answer for part A. Part 1. Part 2, find an expression in terms of n for the nth term. So I'll do that directly. 3n. When I substitute n is equals to 1, my first term is 3, whereas the actual first term needs to be 5. So I need to add 2 here. So plus 2. This is the nth term of this sequence. Part B. These are the first 5 terms of another sequence. Find the next term. So 1 is changing into 3, then 3 is changing into 7. So what's happening over here? Plus 2, then plus 4, then plus 6, then plus 8. So to get to the next term, we'll add 10 to, this was 8, sorry, 10 to 21. So this will become 31, because for the next term we'll add 10 here, which will give us 31 in the numerator. And let's check the denominator now. 2, 4, 6, 8, 10. Then the next number will be 12. So this is the answer. Question number 10. Part A, find the nth term of each sequence. So 7, 13, 19, 25, 31. What's happening here? We're adding 6, then again 6, then again 6, then again 6. Directly we'll write 6, and our first term is 6 at the moment, because when we substitute n is equals to 1 here, we get 6. The actual first term needs to be 7, so need to add 1 here, so plus 1. We get the answer for part A. Alright, I'm clearing the screen now. Part B. Now we need the nth term for this: 9, 16, 25, 36, 49. Now by looking at the sequence, you should directly be able to tell that this is 3 square, this is 4 square, this is 5 square, this is 6 square, this is 7 square. So this is a square series, but they have omitted two terms. They have omitted 1 square and they've omitted 2 square. So this is a shifted square series. So if you remember, we did discuss that if we need to find the n term of the whole series, that is n square. But since they've taken away two terms, so instead of this n, you write n plus 2 whole square, right? And there's another way of doing it, that is, if you simply look at this series and forget about the actual series, which was n square. So look at this. So we have 3 square, then 4 square, then 5 square, then 6 square, then 7 square. So we have square of some numbers. Simply find the nth term for the sequence 6, 3, 4, 5, 6, 7. The first level common the common difference is 1. So the formula will be 1n plus 2. So you simply write n plus 2 here. So you may use either of the methods to get the answer. Alright, the homework for today is the next 5 questions, 11 to 15. Let's quickly go over them. 4, 8, 12, 16, 10, 16 and 20. This is simply first level common difference, so you should be able to do this. This is a quadratic sequence, so you need to remember what we did yesterday. So go over that and then do part B, or revise the quadratic sequences. That was sequence, let me check the page. It's on page number 13, part 5, quadratic sequence or second level common difference sequence. Alright, then coming back to question number 12, that's again a quadratic sequence. So do that. This is straightforward. This is again a quadratic sequence. This is simple. This is an exponential sequence. Every number is being multiplied by 5, so you need to revise what we need to do in this case. This was sequence number 6, that's also explained on page number 13. Revise that. Then question number 15, this is simply a linear sequence, and this is an exponential sequence. Every number is being multiplied by 3. So to revise what we've done before, what we did yesterday, and then attempt these questions. And I'll do the corrections in tomorrow's lesson. Goodbye. Take care.